Okay, today we are going to be working on proving triangle congruence. And a proof is a formal process that we go through in geometry to lay out our reasoning so that others can follow, so that we can convince them or justify and prove that a statement is in fact true. So we're going to walk them through our logic and how we deduced or realized that the proved statement is in fact true. Now, to get you guys started on these, we're going to have the statements already written, and we're going to be writing the justification or the reasons that we knew each of those were true until we get to the end of the proof and prove what was requested to be proven. Okay, so here's our first proof. It says, given that x is the midpoint of line segment VZ and x is the midpoint of line segment WY, prove that triangle VWX is congruent to triangle ZYX. So let's go through and just kind of mark what we know based on each of those given statements. So it said x is the midpoint of line segment VZ. So I see I've got line segment from V to Z and x is the midpoint. That means it breaks it into two equal parts. So those two parts are congruent. Okay. Then it says x is the midpoint of line segment WY. So x is also the midpoint of line segment WY, which means it splits WY into two equal parts, which means that part is congruent to that part. And notice I used a different congruency mark this time. It's not that they're all four congruent. It's that VZ was split into two equal parts and WY was split into two equal parts. And then I noticed, just with my algebra eyes, taking a look, my geometry eyes start blinking, and I see we've got vertical angles here. Vertical angles are always congruent. They're formed by those two intersecting lines, and they are always congruent. So if I take a look at that picture, I see I have a side, the very next angle, and the very next side of that triangle. And so these two triangles are going to be congruent by side, angle, side. Okay, let's see if we can walk through the proof now and see how this works. So it says x is the midpoint of line segment VZ. How did we know that? When we got started, how did we know that? Well, it was given. X is the midpoint of line segment VZ. So that was just given. Now, we have a bank of choices that we can use as our justifications, our reasons over here on the right. And we just numbered them to make it a little bit easier for you. I see given is number 6, so I can put number 6, given. And then number 6, the numbers will just help us find the reasons real quickly, but I still like to write out the reason as a practice and helping me get familiar with what our different reasons are there. So that was just given. That's how I knew that. Now, it says line segment VX is congruent to line segment ZX. How did we know those two marked in orange were congruent? Well, that just followed from the fact that X was the midpoint of that line segment. So that follows from step number 9, or reason number 9, definition of midpoint. And we always abbreviate the words here. Okay. That was from the definition of midpoint. Okay. Then the next statement says, X is the midpoint of WY. How did we know that? That was also in the given statements. So that was given to us to start the process. So that was reason 6 again, given. And we have to know something to start. So we always have some given statements, and we're always trying to prove the proof statement. And then it said line segment WX is congruent to line segment YX, and that's the two marked congruent in purple. How do we know that? Well, that followed from the definition of midpoint. So that's reason 9 again, definition of midpoint. Then it says angle VXW, right there, is congruent to angle ZXY, right there. Remember, your middle letter is your vertex. Okay, so V to X to Y, Z to X to W. How did we know those two pink angles were congruent? That was from the fact that they were vertical angles, and that's rule number 8. Rule number 8, or reason number 8 says vertical angles are congruent. So I'm going to abbreviate that, vertical angles congruent. Okay. Now that we have a side, the very next angle, and the very next side congruent, we can say that the two triangles are in fact congruent by side, angle, side. Okay, by side, angle, side. We need those two are congruent. And side, angle, side is for reason number 3. So we're going to write reason number 3 there up front. Okay, so if you were just writing in the numbers 696983, but it's given, definition of midpoint given, definition of midpoint, vertical angles congruent, and then side angle side. That was the logic of how we proved that we had the parts we needed to prove that the triangles were congruent. Let's try another one. Okay, this time it says line segment QR bisects angle PQS. So let's find that. Here's angle PQS. So it's this angle at the top, and it says line segment QR bisects it. What does it mean to bisect? It means to split it into 2 equal parts. So I'm going to put the same congruency mark, just one single angle congruency mark on those. Notice that when I did that, I wrote them not right next to each other, because when you write them right next to each other, a lot of times it looks like you're just marking the whole big angle. But what we're marking is that the 2 separate pieces are congruent. So those 2 are congruent because line segment QR bisected it, which means it split it in 2 equal parts. Okay, and if you take a look, that's what this proof starts with. It starts by saying QR bisects angle PQS. We knew that because it was given, so that was rule 6 again, or statement 6 again, for given. And then it says angle PQR, P to Q to R, again the vertex is the middle letter, is congruent to angle SQR. And how did we know that? Well, that followed from the definition of bisects. And definition of angle bisector is number 10 right here. So that followed from number 10, definition of angle bisector. So we're going to abbreviate definition of angle bisector. Okay, now it says angle PRQ up here in our next given statement says angle PRQ is congruent to angle SRQ. So let's see that in our picture and mark it. Remember, the middle letters are your vertices. Okay, so P to R to Q, this angle is congruent to angle SRQ, this angle. Oh, that looks a little too much that like you're saying the big angle. So I'm going to try to draw that kind of next to each other. Okay, so that angle on the left is congruent to that angle on the right. We know that because it's given. So that's just reason 6, which is given. It was given at the top of the proof. Okay, and then it says line segment QR is congruent to line segment QR. Well, this is that center piece that connects the 2 triangles. So it is the side, line segment QR is part of the triangle on the left, and it's part of the triangle on the right. And what we can say is that line segment is congruent to itself. It is the exact same size and the exact same measure as itself. And we can say that by reason number 7 over here, which is the reflexive property. The reflexive property, just like your reflection in the mirror, says that you are equal to yourself, right? Something's always equal to itself. The reflexive property. Okay, now look at our picture and see what we have. We have an angle congruent at the top. We have that side in the middle that is congruent to itself and was in both triangles. And then we have an angle congruent at the bottom. That gives us angle, side, angle, triangle congruence. Angle, side, angle will prove the 2 triangles congruent. And angle, side, angle is choice number 1 here. So we're going to call that choice number 1. That was angle, side, angle, angle, side, angle. Okay, very nice. So again, we're just showing exactly how and why we knew each of these statements were true that leads to the congruence evidence that had to be shown to prove the triangles were congruent. Let's try another one. Okay, it says line segment PR. Now you'll notice this time I had to change the choices in the answer bank. These rules are not always the same number. The numbers are just something we gave to try to kind of make it easier to find the rules that we're talking about and quicker for you to write in when we practice in class. So it's not like given is always number 6. We just numbered it number 6 for our use in class today. So it's okay that we have a different 11 and 12 this time than we did in the last group of answer choices, because we need some different options for this group. So here's just an answer bank to choose from for this problem. So it says line segment PR is perpendicular to line segment SQ. So what does that mean? Okay, it means line segment PR is perpendicular to line segment SQ. And perpendicular means that they meet to form right angles. So I'm going to mark that those form right angles, and it forms right angles on both sides there. So that's perpendicular. That's what that means. Then it says line segment PQ is congruent to line segment PS. So here's PQ, this one, and PS is right there. So it means those two are congruent. And those are both our given statements. And then they want us to prove the triangles are congruent. Well, as I spy with my geometry eye, I notice there's something else more than what's given, because they only gave us 2 pieces of information and we need 3 pieces of information to prove triangles are congruent. And what I see is that this side is in both triangles, and we know anything's congruent to itself by the reflexive property. So that gives me a side, and an angle, but I'm like, wait, side, angle. We said no bad words and no AAA batteries. Okay, so side, angle doesn't prove congruence. But when I look a little bit closer in this, I'm like, that's not just a side, angle. Look at that's a right triangle, which means this side opposite the right angle is known as the hypotenuse. And then we have a leg congruent. So in that right triangle this time, we have a hypotenuse leg congruence. If this were not a right angle, we would not have enough information to prove these triangles are congruent, because side, angle is not enough to prove that the triangles are congruent. But since it's a right triangle, then we have a hypotenuse and a leg. That will do it. So let's go ahead and get that written up. Okay, so the first statement they start with is that PR is perpendicular to SQ. And how did we know that? We knew that because it was given here in the top. And so that's reason 6, just given. Then it says line segment PQ is congruent to line segment PS. That was also given. So that's also reason 6 that was given. Now, I like to usually use each given statement to prove the next statement right next to it. But here they just chose to put both of the given statements at the top. That's fine. We'll still get there. Okay, so next it says angle PRQ and angle PRS are right angles. So that's PRQ and PRS. How did we know those were right angles? Well, that followed from the fact that they were perpendicular. So this given is what led to this. So that follows from definition of perpendicular, which this time is reason number 11. Definition of perpendicular. You told me that they were perpendicular, and then I knew that that meant that they meet to form right angles. So that was definition of perpendicular. Now it says angle PRQ is congruent to angle PRS. Well, how do we know that they're congruent? Well, that's because they're both right angles, and so reason 12 tells us that all right angles are congruent. They're all 90 degrees, which of course then means that they're congruent. So all right angles are congruent. All right angles are congruent. Okay, so next it says line segment PR is congruent to itself. It's congruent to line segment PR. How do we know something's congruent to itself? Again, that's like your reflection in the mirror. You're congruent to yourself. That's choice number 7, the reflexive property. And notice I'm trying to color code my reasons to my markings, not so that you can visually see which ones go together. So that was our reflexive property, which I'm just going to abbreviate it, reflexive property. That was number 7. Okay, now looking at our picture, we said that we knew the 2 triangles were congruent then by the fact that we had a hypotenuse in both triangles that were congruent and a leg in both right triangles that were congruent. That's choice 5, hypotenuse leg. So that'll be choice 5, hypotenuse, leg. Okay, very nice. Let's take a look at another one. Okay, for this last one, notice that what we're proving is that 2 line segments are congruent. We're not proving that the entire triangles are congruent. They just want us to prove that these 2 line segments are congruent. Well, that's going to require that we first prove that the 2 triangles are congruent, and then we add on this extra step that we haven't talked very much about, but we want to make sure and know about it to use it today. And that's that corresponding parts of congruent triangles are congruent. So if we can first prove that the triangles are congruent triangles, okay, if we can first prove that they're congruent triangles, then we'll be able to say that their corresponding parts are in fact congruent as well. So that'll give us those corresponding parts that we want to prove congruent. So let's take a look at what they gave us and see what we can come up with on our reasoning so we can prove that these triangles are congruent and then try to get their corresponding parts congruent. Okay, so they said line segment WV, okay, right here, is parallel to line segment YZ. So let's mark that with our little parallel line arrows. Okay, those 2 are parallel. Now, what does that imply to us? Well, I need you to look with your algebra eyes here, and I want you to look for those Z's. When we have parallel lines cut by a transversal, okay, what do we know is true? We know alternate interior angles are congruent, okay? So we say to look for those Z's. Now, those lines might not look parallel in our drawing, but remember, we're not going to assume from the drawing. They told us those 2 lines on the outside are parallel, and we have a transversal that connects them. So if we look for those Z's, we see those are the alternate sides of the transversal, and they're interior between the 2 lines. So those are alternate interior angles, and they are congruent, okay? Then we also could know, if we looked at the other transversal, okay, if we looked at the parallel line and the other transversal, we also could know that these alternate interior angles are congruent, okay, because we had 2 different transversals on each of them, on each of those Z's. There in the crux are alternate sides of the transversal VZ, okay, and interior between the 2 parallel lines. So we have 2 sets of alternate interior angles that are congruent. Taking a look at my picture, I'm like, wow, we just have all kinds of congruent angles, because what I spy with my geometry eyes is that we also have vertical angles here. Those vertical angles would be congruent. So we really know all 3 of the angles are congruent, okay? So, but angle, angle, angle does not prove triangle congruence. We say no bad words, no SSA, which is a bad word backwards, okay, and no AAA batteries. So no bad words and no batteries. So those are the 2 combinations of the letters A and S that don't make, in groups of 3, that don't make a triangle congruent statement. So that's not enough information. So let's look at what else they gave us. Still, that was a lot that we could figure out from the picture. They also told us here that X is the midpoint of line segment WY, that X is the midpoint of line segment WY. Okay, so here's line segment WY, and if X is the midpoint, that means it splits that into 2 equal parts. Okay, well, that's great, because that gives us a line segment. And if we know all 3 of the angles, we can definitely put together a combination that would prove this congruent. Now, this is where, if none of the statements were written for you, you might choose one way to prove it, and someone else might choose another way to prove it. But because we're doing a proof where they already have the statements written for us, we're going to follow what they have written there and get our reasons to justify it, and then we'll use their approach to prove that they're ultimately congruent. So let's get started on that. Let's take a look at that. Okay. So the first thing they said is that line segment WV is parallel to line segment YZ. And how did we know that? We knew that because it was given. So choice 6, it was given. Okay, X is the midpoint of line segment WY. That was also given. So that was reason 6 again. That was given. Okay, and then it said line segment WX is congruent to line segment YX. Well, you can see there in my purple marks that followed from that purple given statement. Because we knew it was the midpoint, then by definition of midpoint, it means it split it into two equal parts. And definition of midpoint is choice 9 over here, so that's choice 9. Definition of midpoint. And you can abbreviate. Okay, then it said angle W was congruent to angle Y. So let's go take a look in our picture. Okay, that was angle W here is congruent to angle Y here. How did we know that? Well, in our blue little line, our blue transversal there, those were alternate interior angles. So that came from the fact that the two lines were parallel. So that's going to come from the fact that alternate interior angles are congruent when lines are parallel. Alternate interior angles are congruent when lines are parallel, and that's choice 12. So choice 12 says alternate interior angles congruent. Alternate interior angles congruent when parallel, when the lines are parallel. So I'm just abbreviating with our symbols there. If you like to just put the numbers, you can. Okay, but I like to kind of put both. Okay, so that gave us an angle that was congruent. So looking at what we're using so far in the proof that they chose, they used that fact that that angle was congruent. They used this side that was congruent. Okay, so what's the third piece that they're going to pick to use? Because we have a lot of angles here. So then they said angle VXW, this orange angle, is congruent to angle Y. Okay, VXW is congruent to angle ZXY. So they chose the two orange angles there. They chose that angle as their third piece. How did we know those two orange angles were congruent? That's because they were vertical angles. If we look over at our reasons vertical angles are congruent is choice 8. Vertical angles are congruent. And so they used an angle, the very next side, and the very next angle. Remember, you can't skip both a side and an angle when you're going around. So this would not be angle, angle, side, because we can't skip from this angle to that angle to this side. Now, we could have done it by angle, angle, side if we had gone the pink angle, the yellow angle, and the purple side, or the pink angle, the orange angle, and the purple side, but we're following their proof, so we're using their reasons. So they chose this angle, this side, and this angle. So that's going to get these two triangles congruent by angle, side, angle. Angle, side, angle is choice number 1. So that's going to be choice number 1, and that's angle, side, angle. Okay, now that gave us the triangles are congruent. Once we know these triangles are congruent, we know all of their corresponding sides are congruent. So we're trying to prove that VX, which is the last two letters, is congruent to ZX, which is the last two letters in the other congruency statement. And so those are congruent because they're corresponding parts. They're in the same position in the two triangles that we just proved congruent. If you look at VX, okay, that's between the pink and the orange angles. If you look at ZX, that's between the pink and the orange angles. So they're corresponding parts in their two congruent triangles. So that's reason 13 that says corresponding parts of congruent triangles are congruent. Hopefully that'll give you a good start into proving triangle congruence. We'll do more practice together, so bring your questions to class.